8 part 3 isn't actually an integration question at all, it's a differentiation question. So we're asked to find the equation of the tangent to this curve at the point P. The point P, recall, is here. So I've got a tangent that looks something like, this always goes badly, but something like that. Sorry, it should actually cut at the point P. And I know also that this point here has an x coordinate of 3 upon 2. So recall the two things that I need to find out the equation for a straight line. The tangent, of course, is a straight line. So the first thing I need is a point on that line. Well, my point on the line is going to be P, and I know the x coordinate, but I don't actually know the y coordinate. But it's not too hard to do. I just substitute it into this. So what is 8 divided by? This would just be 8 over 2 times 3 over 2 plus 1. And if you think about that, that's just 8 over 4, and that's just going to be 2. So my point P is 1.52, if you will. Then, what about, what's the second thing I need? The second thing I need is the gradient at that point. So the gradient is, of course, just given by the derivative. So I'm just going to find out what is dy by dx. So before I do that, recall that y, I can also write this as 8 2x plus 1 to the power of negative 1. Right? So what can I say about dy by dx? Well, I decrease the power by 1. So I bring the power down, so minus 1. The 8 is still there. And then I get 2x plus 1 to the negative 2. And then I have to differentiate what's on the inside. So I have a 2 here as well. So in all this, this becomes negative 16 2x plus 1 to the power of negative 2. But I know the point that this has to work at. This has to happen at the point x equals to 3 over 2. So dy by dx, when x is equal to 3 upon 2, is equal to negative 16. 2 times 3 upon 2 plus 1 to the negative 2. So that's negative 16. 2 times 3 upon 2 is just 3, plus 1 is 4 to the power of negative 2. So 4 to the power of negative 2. That's going to be 1 over 16. So this whole thing is just going to be minus 1. So the equation of our line is y minus y1 equals to mx minus x1. This gives us y minus 2 is equal to negative 1 x minus 1.5. So y equals to minus x plus 3.5. And that's the equation of our tangent line at P.